going to look at a couple homework problems. 41, 44, 47, 50, and 52. So let's see what question 41 is all about. They're telling us that the sine of theta is 1 over 2. And we want to find the measure of an angle in degrees and radians that makes that equation true. So typically the way this works is we're going to use some special triangles. So I'll draw both of my special triangles up here on the top of the page, and I'll probably be referencing these a lot over the course of this homework. So there's my 30, 60, 90. I almost put the angle on the side there. My 45, 45, 90. Sides 1, 1, root 2. Excellent. So now I have to figure out which angle am I going to look at in my special triangle here, such that the opposite side is going to be 1 and the hypotenuse is going to be 2. So I'm looking for an angle that has a ratio of opposite over hypotenuse that is 1/2. That turns out to be 30 degrees, because if I look at that 30-degree angle, the side opposite of 30 degrees is 1, and the hypotenuse is 2. So that is the theta that satisfies that, 30 degrees. But they wanted the answer in degrees and radians, so I had to convert theta to radians as well. So I have to multiply by pi over 180, and then reduce that, and I get pi over 6 radians. So notice that makes, if theta was 30 degrees, or pi over 6 radians, that makes that a true equation. So the sine of 30 degrees does indeed equal 1/2, and the sine of pi over 6 does indeed equal 1/2. Those are both true equations. So I'm looking for the theta that makes that equation work. Okay, let's look at 44. 44 says the cosine of theta equals root 2 over 2. Well, look at the 45, 45, 90, because the way I've drawn it, it has sides 1, 1, legs of 1 and 1, and that triangle, and a hypotenuse of root 2. Now, so if I'm looking at one of those 45-degree angles, I could say that the cosine of 45 degrees equals adjacent over hypotenuse. So if I'm looking at this 45-degree angle, the adjacent side is 1, the hypotenuse is root 2. But 45 degrees, that's actually the answer to the question. Now that's because 1 over root 2 and root 2 over 2, they're actually the same exact value. Because if I took this 1 over root 2 and I rationalized the denominator, if I multiplied the fraction top and bottom, so if I multiplied by root 2 over root 2, I multiplied straight across, I would get root 2 in the numerator. And in the denominator, I would get root 2 times root 2, which is root 4, but root 4 is 2. So 1 over root 2 and root 2 over 2, they're the exact same value. They have a decimal equivalent of approximately 0.707, if I'd rounded to 3 decimal places. So you just got to be careful that sometimes you'll see problems that have a 1 over root 2, sometimes root 2 over 2. They're the exact same value. So you just have to be aware of that. So one answer, 45 degrees, but I need that answer also in radians. So I'll convert that. I'll multiply that by pi over 180, reduce, and I'll get pi over 4 radians for my two answers. Excellent. Let's move on to 47. 47 says tangent of theta equals root 3 over 3. Okay. Well, let's look at the 30, 60, 90. If I look at 30 degrees, the tangent of 30 degrees, tangent is opposite over adjacent. If I look at that 30-degree angle, the opposite is 1. The adjacent side is root 3. Now, again, if I rationalize that denominator, if I took 1 over root 3 and multiplied it by root 3 over root 3, I would get root 3 over root 9, which is 3. So notice, again here, that 1 over root 3 over 3, they're the same number. So, the theta that I'm looking for here is 30 degrees. And I've already converted that to radians up above, so I know that that is also pi over 6 radians. Let's check out problem 50. Problem 50, it says solve for the variable shown. They give me a picture of a right triangle with a z on the hypotenuse, 39-degree angle down there. And they want us to solve for z. So I need to write an equation using sine, cosine, tangent, secant, cosecant, or cotangent. I need to write an equation that involves the hypotenuse, z, because that's what I'm solving for. So looking at what I'm given, though, I'm given that this angle is 39 degrees. So looking at that angle, 23 is the adjacent side, and z is the hypotenuse. So what trig function involves adjacent and hypotenuse? That's cosine. Cosine is of an angle is the adjacent side divided by the hypotenuse. So I could write the equation cosine of 39 degrees equals adjacent side, which is 23, divided by the hypotenuse, which is z. So now I'm just going to solve this equation for z. So I'll multiply both sides by z to get it out of the denominator. So I get z times the cosine of 39 degrees equals 23. And then I'm going to divide both sides by the cosine of 39 degrees. And I get that z equals 23 divided by cosine of 39 degrees. Now I can approximate that. I'm just going to do that on my calculator, but I have to make sure that I'm in degree mode. So hit mode on your calculator, and notice how on the third option, the third line, it says radian in degree. Make sure degree is highlighted, so that when you type in 23 divided by cosine 39, the calculator knows that that 39 is supposed to be 39 degrees, not 39 radians. And it is 29.595. And there was no units here, so don't need units on z. That is my answer. Now notice I could have done this, I could have written a different equation here. I could have actually solved for the top angle in the triangle, because all of the three angles have to add up to 180. So I could figure out that that top angle is 51. And then I could write the equation using that top angle, so I could write the sine of 51 degrees. That's the opposite over the hypotenuse. Well, the opposite side from 51 degrees is 23, and the hypotenuse is z. So notice that's a different equation than the one that I wrote, but it's still a valid equation based on this triangle. And if I solved that out, I would get the exact same answer for z. So there's a lot of different equations that you can write for any particular triangle, but as long as they're valid, based on the definitions of the trig functions, sine, cosine, tangent, cosecant, secant, and cotangent, then your answer is going to work out. So you could potentially have different work if you look at my answer sheets online, the PDF files, or if you watch some of these movies, you might notice that you're going to be doing problems a lot of times differently than I do them, but we'll arrive at the same answer a lot of times. So just keep that in mind. I'm going to squeeze in 52 here so I don't have to go to another page. I get a triangle, 43 degrees labeled down here, x, and 14. So using that 43 degrees, x is the opposite side, 14 is the hypotenuse. So opposite and hypotenuse, I could use a sine equation here. So sine of 43 degrees equals opposite side, which is x, divided by the hypotenuse, which is 14. This equation is actually easier to solve than that number 50 equation. All I have to do is multiply both sides by 14. And I get x equals 14 times the sine of 43. I'm just going to do that on my calculator. I'm already in degree mode because I checked that in problem 50. So I just type in 40 sine of 43 exactly as I've written it down. That should be exactly what you're typing into the calculator. You get 9.548. And again, no units. There's no units given in the problem. So that is how big side x is.